Hello, this is Whitney Otan, geology professor in the Department of the Earth Sciences, and I'm here today to talk to you about today's lab exercise in ESC 195. Today's topic is tsunamis and the hazards that tsunamis can generate. As you know, tsunamis are catastrophic ocean waves, and the first thing and an important thing to point out about tsunamis, they are not the typical ocean waves that occur when the wind blows across the ocean and generates the swash and backswash that you see on a fair weather day on the beach. So the wind produces most of the waves that we see in the ocean, but tsunamis tend to be generated by catastrophic disturbances of the ocean floor or the shoreline near the oceans. Basically, the energy that's generated in a tsunami is associated with the displacement of the ocean water. So if a landslide or a earthquake or a volcanic eruption generates a disturbance to the ocean floor, that has the potential to generate a tsunami. An additional factor that can cause tsunamis is asteroid impacts. If a meteor lands in the ocean, it has the potential, if it's large enough, to displace a significant amount of water and can cause tsunami also. Now, tsunamis have different characteristics as waves than fair weather wind-driven waves. The first is that a tsunami has a very long wavelength and a very small amplitude. So basically, as a result of this, the tsunami wave disturbs the entire water column and can be sensed as a pressure change in the bottom of the ocean, whereas a surface water wave will dissipate over a very short distance that's associated with the degree of the speed of the wind. So that's one primary difference, and this gives us the ability to put sensors on the ocean floor and detect the passage of a tsunami wave, which helps us in our warning systems. The tsunami wave moves very, very rapidly. It moves at speeds of approximately up to 700 kilometers an hour. That is 400 miles an hour, and that's approximating the speed that jets travel as they cross our country. So this very fast-moving wave with a very low amplitude shows very little notice until it approaches the shoreline. And the first thing that happens is the water on the beach will tend to run out. The swell will wash out seaward, and you'll get a small drop in water level, then a very rapid run-up as the wave comes onshore and pushes inland. This is where the hazard and the damage and the disaster potential tends to occur, because basically if the run-up is very high, it could cover a large area, and also if the run-up is high, it could swell to a very high elevation along our coastal structures, such as beachfront developments, condos, and things of that nature. So the actual nature of the run-up depends upon the overall depth of the ocean that the tsunami is passing through, the shape and the configuration of the shoreline. The tsunami tends to funnel into bays and rise up higher into bays as a result. The overall slope of the shoreline, a very low sloping shoreline, will allow the tsunami to run up further as opposed to a steeper shoreline. And then the last, the distance from the source. If a tsunami occurs offshore near a coast, it can very rapidly create a run-up, such as what you saw in Japan a couple of years ago, what happened in Chile a few weeks ago, and also what happened in Banda Aceh in Indonesia back in 2004. So basically, what can happen once a tsunami is generated, an area of shoreline that's affected by tsunami can experience multiple run-ups. So the tsunami does not come essentially as one wave that goes away. There can be several tsunami waves impact the coast in an individual event. The other is that the run-up can go very high in elevation, depending upon the coast and the configuration, but you can see tsunami tsunamis have run up in excess of 100 feet above fair weather shoreline. So as a result, in some coasts, one would have to go to quite high ground to get away or escape the effects of the tsunami. So in general, tsunamis can produce very catastrophic effects when they occur in populated areas, and a large earthquake especially will be the trigger of some of the greatest tsunamis that we have seen in recorded history. And these tsunamis can run up several hundred feet up a landscape and can inundate a coast with multiple ocean waves, obviously producing very great damage and catastrophic occurrences as a result. So with that, enjoy your exercise. Have a nice day. This is Whitney Otan signing off.